Okay, hello everyone. Okay, welcome to the Local Food Production Systems project. This is one of our projects that we have funded through the U.S. Department of Agriculture. And it's a project that demonstrates how people can grow their own food, particularly fruits and vegetables, regardless of where they are. And basically all you need is just some adequate sunlight. Okay? So what we are demonstrating here is part of the systems. We have the raised bed gardening, and we have the container gardening at the back. Raised bed, right now we have the sweet potatoes. If you want to come close, how many of you have seen how sweet potatoes grow? Okay, if you haven't, you can come closer. And we are using this material so that we can keep it for a long time. This is material that you can order online, but you don't have to use this one. You can use lumber, piece of lumber, you can use piece of logs. Some people use bricks, just anything that will lift your garden off of the ground. And the advantage of this is the ease of keeping weeds out, ease of watering. So you don't have to have a whole field to try and weed and water and things like that. And again, it is raised, so when you're working in it, you don't bend too low. So if you look over here, it's pretty clean. And when our technicians come, they just work on this area. They don't have to work on around. Around, you just come with a weed eater, or those who don't mind using herbicides, you can just spray some Roundup and kill the weeds around it, and your garden stays clean. So if we were to grow these potatoes in the ground, we'll be covering much of this area, and we'll be fighting all these grasses and all that. But you see how easy it is. Now, you can even set this one on a concrete. We do have a school that, a middle school, that we are working with, Quest Elementary, I think, no, Quest. And they had us set the garden on parking lot. So even areas where you don't have any soil, you can set it up. You just put the mix. Right now we have put in just the garden soil, and we planted on it. You can use purchased garden soil that we have in the containers. Any potting mix will do, but it makes it much easier. This bed takes about, 14 plants, and each plant can give you an average of about 5 potatoes. So 14 times 5, that gives you quite a number of potatoes. And it's an easy way of growing that. So let me show you some of the potatoes and how they produce. Over here, this one is a little exposed. Okay, you see, what we planted was just a single slip, sort of like this one. When you go to the virus index plant, the greenhouse and all that, you learn a little bit more about that. But you normally cut a slip that much size, and that's what we stick in the ground. Once you stick it, it grows, and there are potatoes growing all around. And all this cracking shows how many potatoes that are growing in there. And maybe we can get this one out. Ebenezer, can you carefully without? Okay. So this is the size that we have right now. We're looking at another 3 weeks or so before we harvest them. Okay. So down there you have anywhere between 3 to 9. It all depends on how many the plant set. But you can grow such a nice potato just in the backyard, and you don't have to till the whole garden, just a raised bed. With container gardening, it is even much easier. A container, you can even set it up on your patio if you live in apartment, or any space really that gives you some light. And you can grow different crops. Within the containers, we have 2 different types of tomatoes. And if you want to know the names, we can give them to you. But again, any space that can hold some soil and you can have some light to it, you can grow your crops, lots of them. Actually, we've harvested quite a few tomatoes here and cucumbers, okay? And then to our right, you see we have some watermelons there. What we are demonstrating here, we planted them rather late when it was really very hot, and that's why some of the varieties are not doing as well. But the thing we wanted to show with our watermelons is that when you grow them, you don't have to to grow only one kind. We have watermelons here, like this variety here, I think is the Sugar Baby. That watermelon gets just to that size. It's just a 1 serving size watermelon. If you go to the store, normally you get big watermelons, and when you cut it up and you don't have that many people in your house, it's a problem keeping it in the fridge and all that. So these are 1 serving size watermelons, very sweet. And then we have some that are bigger size, and we have some that are seedless. We have some that have yellow meat inside. So the main idea here is to demonstrate that when you grow your garden, and yes, again, you can also grow them in the containers. When you grow your garden, just select different types of varieties of what that is, whether it's tomatoes, whether it's watermelons, and there are some that will mature earlier than other varieties, okay? Lack of a garden, lack of a farm really should not be a reason for you not to grow fresh foods, fresh, healthy foods, okay?
Sweet potato, clean seed production, and like I was saying, by nature, viruses build up in sweet potatoes, and that's because what you find, for the farmers to get planting material, what they do at harvest, they go through those roots, and then they select from those roots for the next year's crop. So they'll take a portion of roots out that they'll come in the next season, and then they, what we call bed them out in the field. You prepare an area, you put them, you cover them with some soil, and then they begin to sprout. And as those sprouts grow into the vines, or what we call slips, those are what they come and they cut to get planting slips, to get sweet potato slips to plant the next season. Now, every year's crop it's a generation older. And then when I got here, I found farmers were using 6 and 7, 8 generation old seeds. Now, because of that situation, every year, viruses multiply in those seeds. So some of those seeds were so laden with viruses that by the time they planted them, it really affected their crop. We know viruses can affect your yield by as much as 40%. So, some farmers were going into the field knowing that 40% of what I can harvest here, I'm just going to lose to nature, the quality of my seed. UAPB is cleaning up planting material. We take planting material to the laboratory, and through tissue culture, we virus index them, make sure they're clean, no viruses. And then we bring those plants to our lab. Now, when you go to the lab tour, you'll actually see all of that operation. You see how the guy has the plants there in the test tubes, and he'll show you how we grow them out in the lab, in the greenhouse, and we multiply them out in a high tunnel. But then once we get them into the high tunnel and you multiply them, you get thousands of slip growing in the high tunnel. You then bring them to the field, and ideally you want to have them in a field away from any other sweet potatoes, because you don't want to have them close to material that might have already been, virus loaded. And you also want to have them in clean fields. And in this year, we have some Bogart, and we have another variety, some Orleans. But I mean, you look at our field and you see, this has, to me, a little bit too much weeds. Although we've done a good job keeping out the weeds that we don't want, the morning glory weeds and not a lot of pig weeds. But you really don't want to have any weeds. We've been struggling because of the rain situation. It's been affecting our application of the herbicides. But this is where we go, and we generally go for seed production, which are some of the smaller size sweet potatoes. Of course, you won't go take a nice, big, rosy sweet potato and decide I want this for seed next season, because, that should be in the supermarket. You don't want to put that for seed. So you know, sometimes we'll go in and harvest a little earlier, depending on the variety. If you have a variety that goes for 100 or 105 days, maybe you want to get it out at 90 days. That gives you good seed-sized potatoes. And then we make that available to our farmers at a very subsidized cost. So farmers can come here for virus index planting material. Now, when they get our seeds, they can then save from that material for the next 3 or 4 years, because it's not recommended you save after maybe your 4th generation. So when they get a 1st generation seed from us, they're at liberty to save from that for another 3 or 4 years, and then maybe they need to come back to us again. So we make this available to them at a very subsidized cost. We're actually, for some of the larger farmers that are more organized, what we do, we can actually provide them with the slips itself, and they can raise their own seeds. A lot of the smaller and the limited resource farmers, we prefer to give them the seeds because they're not all that organized in terms of raising the slips. They too suffer a lot from weed issues. So this is kind of the, you know, one of the big activities out here in terms of what we do for sweet potatoes. And like I said, we don't raise large acreages here because we're not in the issue of sweet potato production. We're just trying to raise seeds for limited resource farmers.
So today I'm going to show you sweet potato plots here. So the idea here is that we are trying to include a cover crop in rotation with sweet potato. So the signs you see here are cover crop that I'm going to plant in the fall. So they are not what you see here in the field. What you see are sweet potato. So you know that farmers, when they grow sweet potato, they have to till the ground and plant on raised beds. That system of producing sweet potato can in the long run can be very harmful to the soil quality. For example, it can reduce the organic matter content. It can cause a lot of erosion, and in the long run, it can reduce the soil quality. So what we are trying to do here is that we think that after harvesting the sweet potato, we can plant a cover crop to keep the soil covered until after the spring, when it's ready to plant the sweet potato again. That system of production is going to be sustainable because it's going to allow us to see, for example, if we are building up the soil organic matter content, and also when we grow sweet potato, we're going to see if the yield, the soil storage, the root yield is going to increase. So, but here we are interested in the yield, but we are also interested in measuring that soil quality. How do we measure soil quality? We're going to measure things like physical properties, like the soil compaction. Does the cover crop help the soil compaction? Because some of these soil contain a lot of clays, and then they can be very difficult to till. And also, it can require a lot of energy when you are trying to harvest your sweet potato. We think that the addition of soil organic matter is going to help in the long run by helping, for example, reducing the energy that is used to harvest the sweet potato. So we can measure also things like the pH, because the pH is going to affect the nutrient availability in the soil. And that can, if the nutrients are available in the soil, we can reduce the amount of fertilizer we are going to use. So we can measure also chemical properties by looking at the nutrient content and nutrient content and how those soil chemicals are improved, whether the soil is holding more nutrients than before. And other measurement we can use are the microbial activity in the soil, because by keeping adding those cover crop in the soil, as they decompose, the microbes diversity and function is going to improve tremendously. So we are going to measure those indicators, and we'll see how the system is going to affect that. And we think that we can get some data that we can share with the growers.
What we do here is breeding or developing new varieties of cowpeas. And as you know, cowpeas is grown and marketed in two situations. Dry, I think, how many of you have seen this? I'm sure everybody, especially dry peas, and what we call fresh. This is the extent the market has come now, because what I've been doing every time I go to Walmart, Brookshire, all these grocery stores, trying to get every new product brand. So here we have, Melissa, how many?
We have 39 cans of peas right here.
Yeah, 39. So those are 39 brands. Wow. Well, brands, yeah. So I suppose the recipes you want to call them, because this is the same one here, ranch, I suppose, yeah. Ellen, food club or food cup, something. You can read them here. 39 of them. So over the five years I've been collecting them. This is what I've got. That is different in each. And also for fresh peas, those are the brands which we have got. Actually, what I intend to show here is that cowpeas are quite important to the farmers, right? And of course to those of us who consume. And our purpose here today is to show and tell you some of the varieties we have developed as they compare to those which already have been developed, which are in the commercial. Then we come to our actual demonstration. I think you will see it as you go there. Oh, you can read them. Early Scarlet is a very established variety. This was developed in Fayetteville, UA Fayetteville, some years ago. And PB1 there is a red. That is one of our new varieties, which we developed over the past 10 years. But that's how long it takes, or longer. And Mississippi 2, that one there, you can see that one. That one just came to the market last year. And I think it is obviously developed from Mississippi State or something. And the next two, again, some of our new varieties. If we had time to walk here, you'll be able to see. This is a red one. Yeah.
How do you tell if they're ready?
Okay, this one particularly, maybe you'd be interested in this. This is a new variety which just came into market. And what we do in our program is to take the risk first, to evaluate it and see if it works. Then we may recommend it to the farmers. But right now, I'm not sure about this one. We plan. Compare it to ours here. This one here is close to maturity.
Oh,
this one here. You see, it's tinted. The color is the tinted one, tinted color now, reddish. That means it is like that one there. You see? This one?
The one that's the red.
This one here, reddish, red, yeah.
So
that is what shows maturity. But this one will be fully mature in the next 3-4 days. What is the name?
Michael Griffin.
Michael, yes, Mr. Griffin. How much? What do you think about the yield of this? What do you think this will yield? Yeah, this is our latest variety we developed here, and we are going to be moving it to the farmers. I mean, first we will try it in a large scale. Again, find the risks which are there, and then
These shell easy too.
Yeah, yeah.
Oh, they do?
They
Then those purple hoes.
Yeah, the shell is.
They shell easy.
To our organic rice research project. This is my graduate student again, and he will introduce what we did from last year and this year, because we just started this research.
Okay, thank you. I'd like to welcome you again in our organic rice display. Me, Dr. Huang, and Dr. Sixty, we are working on our organic rice experiment since last year. And I'd like to tell you about something why we're working on organic rice. So what can be the benefits of organic rice over conventional farming practice? What do you think?
Tastes better.
More nutritious
Oh, yeah. Like there is so many benefits of organic rice. Like organic food is safer and healthier, right? So whatever food or food product that is made from the organic rice we eat, that will be more safer and healthier. And since we don't use any kind of like pesticides and chemical fertilizer, so there will be less water and soil pollution, and there will be less human exposure to pesticides, right?
Right, that's it.
And also organic farming practice, it's like environment friendly and sustainable farming practice. And there is one more important thing, that is organic soil can stock higher amount of atmospheric carbon dioxide. So when soil stock more amount of carbon dioxide, so the concentration of CO2 will decrease in atmosphere, so it will help to reduce global warming to some extent. So now I'd like to describe about what we did since last year and this year. So last year we planted 15 rice varieties, and we used water seeding method as a method of planting, and we used flooding to control the weeds. Basically we are focused on controlling weeds in organic rice. And from our last year experiment we found 2 rice varieties that were Jasmine 85 and Rondo. They were more weed competitive. And we have also planted those rice varieties this year. And this year we also have planted hybrid lines as well as selected rice varieties from the last year. And this year we have used plastic mulch to control the weeds. So why are we using plastic mulch? Because when we use plastic mulch to control the weeds by covering the soil with the plastic mulch, so we can see those mulch as black in color. So they will absorb the solar radiation and they will trap the radiation and increase the heat inside the mulch. So there will be higher temperature inside the mulch. So because of the high temperature, the weed will be suppressed. So we have used plastic mulch to control the weeds, and so far we are getting good results this year. And we are using hybrids lines because hybrids can grow faster and they have higher tillering capacity, they have better seedling establishment, so they can compete with weeds better than other varieties. Now I'd like to talk a little about how we applied fertilizer. You might be surprised, right? Because there is plastic mulch, so application of fertilizer is little maybe like crucial. So before applying the fertilizer, we send our soil samples for analysis, and based upon the analysis results, and we just found out what is the required dose of fertilizer, and we use nature shape. It is organic fertilizer, and it contains 8% of nitrogen, 5% of phosphorus, and 5% of potassium. So we applied at 120 lb nitrogen, 90 lb phosphorus, and 120 lb potassium per acre. That is our standard dose, and we split that dose in two and applied it at 2 different times. First we applied at around after 35 days of sowing, and the second we applied after about 60 days after sowing.
Would increasing potassium help or hurt the product or the crop?
Oh yeah, of course, yeah, it will help. And so far, plastic mulch, it has effectively controlling the weeds, and rice are growing very well. And we are collecting data to analyze our results, and we'll be looking for the difference in the yield between the rice varieties, and also be looking for yield attributing characters that may be different between the rice varieties.
My name is Sean Francis. I'm the Extension Horticulture Specialist here, and I work with vegetables. Specifically, one of our bigger projects is the Sweet Potato Foundation Seed Project, and it's all about providing clean or what we call virus-free planting material for our farmers, sweet potato planting material. Now, this is a weed control demonstration, and in my work with farmers that are growing sweet potatoes, weeds are always one of their most troublesome pests. For some reason, we do not have a whole lot of herbicides registered for sweet potato protection in Arkansas. So what we have been doing, and the other problem with that, if you don't have a range of herbicides, if you keep using one herbicide over and over and over, then you run into issues with resistance. The weeds pretty fast build up resistance to those herbicides. So in an effort to get a range of herbicides that we can put our hands on, we've been communicating and collaborating with our colleagues out in Mississippi and Louisiana. Of course, you know, those are two of the major sweet potato producing states. And we have been borrowing from some of their work or kind of using some of their recommendations and experimenting with it here to see how well it works in Arkansas conditions. So out of Mississippi, a standard recommendation is the use of Valor herbicide, which is a good herbicide for broadleaves and sedges. The thing is, in sweet potato production, there's a big issue with pigweeds and morning glory. Those are two of the most dominant pests. And those weeds are actually broadleaf weeds, which means they're the same type of crop like the sweet potato. So anything that's going to kill a broadleaf is going to kill your sweet potato. So you just can't use it indiscriminately. It's always a situation of when you use it, your timing, and your dosage. And if you don't get it right, you actually affect your crop. So we've been experimenting with Valor for control of the broadleaves, a lot of the morning glory, which is a cousin to sweet potato. By nature, they naturally carry the viruses that we're trying to keep out of the sweet potato. So that's always a big issue if you have morning glory in your field. There's some other issues, like I said. I mean, that Valor, because of the nature of it, it's going to kill your sweet potato if you don't manage it well. So what we have here are 4 plots, starting from the one at the top, where we've varied the rates of Valor that we used. The recommended rate is 3 ounces per acre. So our first plot received 3 ounces per acre. Then we decreased it to 2.5 ounces per acre in this second plot here. This is our control. This plot received no treatment. And then we had 2 ounces there and 1.5 ounces in the end. And the Valor, we went ahead and put that Valor in 5 days before we planted the sweet potatoes. If you plant right behind putting that valor out, it also affects your crop. And was expected to give you a decent control of the broadleaf weeds, you know, your pigweeds, your morning glory, and those types of weeds. For the grasses, we followed up with an application of Command 72 hours after planting. And then 3 weeks after, 21 days after, then we did some cultivation between the rows, and then we put an application of Dual Magnum on. And the Dual Magnum, that's a good herbicide for the control of nut sedge, which is another troublesome pest in sweet potato production. Now, if you can take a look right up to, if you can just back out a little bit, Kat. If you take a look right up to the top end, the plot to the very top, and you see, particularly on that end row, you see it's as though you don't have, you know, it looks as though there's a fair amount of skips or from very small plants. And what that tells you is that in our conditions, at 3 ounces per acre, you'll damage some plants. And that's at 5 days prior to planting, which means that, you know, that's something we probably won't want to recommend to our farmers, because of course you're going to have damage. At 2 ounces per acre, 2.5 ounces per acre, which is this plot here, it looks like you have a much better plant stand, so you don't have as much damage on this plot, and there's a fair amount of control here. Of course, this is our control plot, no herbicide on this, and if you look, you see the pigweeds coming up there, there's some morning glory in between there. So, you know, everything, of course, we expect that. You know, fair amount of nut sedge, because this didn't get any treatment. This is what we show our farmers. If you don't treat, this is where you're going to end up with. But if you look at the plots that have gotten 2 pints of valor per acre, we do have a fair amount of control out there, but I've noticed to the edges of those plots, we're beginning to see some of the weeds coming up, particularly the pigweed. Pigweed is really a troublesome weed in sweet potato production. And to the end plot, where we have just 1.5 pints per acre, still, you know, there was some issues with that plot, because what had happened, we had some flooding issues down the end of that field, and because of water, you know, prolonged amount of water there, I think there was some issues with the herbicide there. So, you know, you didn't have a good plant stand, even though you had the lowest rate of valor down there. And I'm also seeing some evidence of pigweeds on that plot. So, given this trial and what we've seen here, we'll say around 2.5 ounces rather of valor per acre gives you a decent plant stand, and it also gives you good enough control. Now, mind you, we haven't gone in here to sample weeds and take biomass and do all of that. This is just a visual type demonstration. Based on what we've seen here now, though, this sets us up nicely to really plan for next year's activities, because, you know, we know 5 days before transplanting, when you apply that valor, you still see some damage at 3 ounces per acre, but not a lot of damage or no damage at 2.5 ounces per acre. Now, we know it's not always ideal to put your herbicides out, and, you know, sometimes if you wait 5 days to plant, you can get some rain coming in between there and mess up your schedule. Now, next year, we can then go in and then tinker with the days prior to transplanting. So maybe we can try this 2.5 ounces per acre at 3 days prior to planting. And if that works, you know, we can probably try it at 2 days, maybe 1 day prior to planting, and see what works best for our farmers. But until you go through those trials and you have hard data there that you can relate to, you know, you really don't want to be making recommendations to your farmers. The other thing, part of it too, is having this here to bring them to see, because our farmers, you know, a lot of times they're kind of set in their ways and they don't want to change from what they've been using. And like I said, if we keep using just a handful of herbicides year after year on those same plots, we're going to have severe issues with resistance to those herbicides. So, like I said, this was intended just to, give us first-hand information on what works, what rates work, and in terms of your time prior to planting. We have some ideas now, and it sets us up going forward to really tinker with those ideas, tinker with some more rates, as well as even the timing of putting your command on and your dual magnum, because if you don't come with your command and your dual magnum after you put that Valor out, then you don't control the grasses. The Valor is a good herbicide for control of the broadleaf weeds, but you do need the command and the dual magnum for your grasses, dual magnum in particular for the nut sedge. Now what we have done here, we did put the command 72 hours after as a pre-emergent control, which means that was intended to control the weeds before they came up. And then at 21 days after, we did some cultivation and put that dual magnum there to kind of hold back the nut sedge. Now what we found was on some of the plots, the nut sedge had already begun to come up at 21 days. Now we need to go in now and tinker with that 21-day period in which you put your dual magnum on to see if we can maybe put it on in 14 days and get more effective control. Because what I've noticed, you still have nut sedge issues here putting that dual magnum on 21 days after. We probably need to come in maybe at 14 days. We probably need to put that dual magnum on as a tank mix with the command just 3 days after and see how that goes. So I think this demonstration sets us up really nicely going forward in terms of what are some of the things we can do, and then maybe in another season or two have some really concrete recommendations for our farmers.
So, okay, I'm the Young Park, the Agriculture Department. I'm just demonstrating the honeybee hives, and this is kind of a basic hives. And this is a deep box, and this is the honey box. We call the super box. And if this is have the outer cover, and you lift it up, we have the inner cover here, and that has the two cover because that is kind of the air insulation, so that they just prevent too much the congested. And also, if you look at the inside, we have the frame, like 10 of the frames, and here is like a frames, and they have different types of frames here. And it could be the plastic or the yellow color, black color, and the white color, and the natural, the wax foundations. And this one is without that. So if I remove that, and this is the queen bee's stay, okay? And this one is the here is like a queen bees, and we have to mark down so we don't want to like harm the queen bees, because we don't, if we accidentally injure her, and that whole colony is kind of jeopardized to die. So we make the mark down, and we have the queen bees have a little bit large abdomen here to deposit eggs, like here queen bee abdomen is the plug into the cell, and the cell to deposit eggs. And so if they deposit eggs, and here it looks like the legs, one egg, they just always deposit only one egg. And if you have a multi-eggs, that is not queen bee deposit eggs. That is a worker bees, egg-laying the worker bees. That means there is no queen bees. So anyway, they have the one lay eggs. They hatch to the larval stage and pre-pupated. And this is kind of lie down, but this time they going up, right? And the head part, they pupated like that. And then they right before they emerge. As soon as they emerge, and the worker bees approach to them and just feeding, and so they just get activated. Okay, and here is we call the Trophalaxis, and they are sharing the nectar, and so they just collecting the more nectar, and eventually they matured, they can produce like this kind of the honey, right? And here is like a cross section of the comb, and you can see both sides have the cell, and they have spaces. We call this is bee space, and bee space means two bees are stand together, and if there's a wider than that space, like like a half inches or something like that, or 1 centimeter, or the wider than that. And problem is they making new build between that. That is making cause the congestions for that. So that is we don't want to do that. And here is like a opened seal, cells and unopened seal, and is unsealed the cells. Unsealed, they have still the larval stage here. Here is the seal that's pupated, and then they have the bee bread here and then honey around here. So nursing bees don't have to travel too far from the brood area, so they can feed the decent way. Okay, and the springtime, most time they're swarming, making the cluster like this, and that is a natural split during the springtime, and they leave the old queen bees with the young bees the left for the new hives. And the original nest, they have like a new queen bees, and the old bees are stay there. So they naturally split it. So they just they're happy to they're making the new hives. And this one is like foragers. They have a lot of pollens cover the bodies, and pollen sacs here they bring in. And here is another the materials we call the propolis. This propolis is actually antimicrobial, and actually that is cover the surface, and they have crevices. They just seal with that kind of sticky materials, so prevent the pest coming through that. So, and we have here is the wax, and this one have a lot of materials. They can making the honey, as I mentioned that. And here is the wines, and we can make it the wax, and eventually we making the candles. All right.
At UAPB, we are developing a mass multiplication of virus-indexed sweet potatoes, because the virus is a major disease in sweet potato. It is more than 30 to 40 different viruses are reported in sweet potato. At UAPB here, we are developing the virus-indexed sweet potatoes through the shoot tip meristem culture. The shoot tips are the fast-growing tissue. We cut the shoot tips and put them in the tissue culture and develop the virus-free plants through the tissue culture media. And then finally, we are checking for the presence of virus in the plants. Those plants which are free from viruses will be developed into the insect-free greenhouse in the greenhouse, and then multiply in large scale in the hoop house and given to the farmers. These materials are virus-indexed. And we are replacing once in 2-3 years, we are replacing the material so that the farmers will get benefit out of the virus-indexed sweet potatoes. So this material will be ready before your planting season. You can come here, and we are giving this material G0 plants through the virus indexing protocol and giving to the farmers in a nominal price. So when you are ready for planting, come to us before April to May. The material will be ready, and collect the sweet potatoes for your planting.
So what we're working on in the livestock group this year is organic and natural dewormers. One of the issues that we're facing in the small ruminant industry is a blood-sucking parasite that will kill our small ruminants, and that parasite has become resistant to most of the dewormers that we use today. So we're trying to find some alternatives, not only to combat the resistance issue, but also because a lot of sheep and goat producers would like to be able to produce their animals naturally or organically. And right now what we're testing is black walnut hulls. We're using 10 grams of black walnut hull per day, which is what people are generally using in the industry. And we're feeding that to half of our goats, mixed up with some ground corn and molasses to make it stick. The other half of our goats are getting the ground corn and molasses alone, so that everybody gets the same thing except for the ground black walnut. And then they all get turned out in pasture together to eat throughout the day. The way that we're determining whether this works or not is we're collecting weekly weights. We want to see if they're losing weight or gaining weight. Wormy animals will lose weight, and animals in good shape should be gaining weight at this time of the year. We're checking body condition scores to make sure that they're maintaining or growing in body fat and muscle, because again, wormy animals will be losing those two things. And we're also looking at FAMACHA scores and fecal egg counts. So the FAMACHA scores have to do with anemia. And the blood-sucking worm as it sucks blood out of the animal, causes a reduction in the amount of blood inside the animal, and we can look at the conjunctiva of the eye, that's that pink tissue around the eye, and as it becomes increasingly pale, we know that we're starting to see a problem, and we go from the 1 over here on my right all the way down to a 5 over there on my left, which is dangerously anemic, and by the time they get to be a 4, we want to treat them. When we see animals reach a level 4, we're going to go ahead and treat them and take them off the study. But this tells us whether or not the dewormer is working in regard to maintaining the level of blood that the animal needs to have. The other thing that we're working on are fecal egg counts. Because this is a gastrointestinal parasite, it lives in the stomach, it lays its eggs in the stomach, and then the eggs pass out through the feces, and then the larvae develop in the feces, crawl into the grass, and then the sheep and goats eat them, and the cycle starts again. So we want to look at the number of eggs in the feces to determine whether or not we're either stopping reproduction in the worm or reducing the number of worms. We should see the count of eggs fall. To do that, we collect a sample, and it's simple stuff. We just collect that in a little plastic cup. We'll grind that up in some salt water in a little tea strainer just to keep the main leftover material in the feces out of the sample. And we use the spoon just to mash the fecal sample up. Then we'll use this special microscope slide. This is a McMaster's microscope slide, and it has a little gap in between the cover and the bottom, and there's a grid that you probably can't see on here, but we do have a fact sheet, fecal egg counting for sheep and goat producers, where you can see this. And then we'll examine that under the microscope, and what we're looking for, those are the worms that you may or may not be able to see based on the glare, and down. And then this is what the eggs look like under the microscope. And so we're counting the number of eggs per gram of feces, and we would expect to see that decline over time if the dewormer is effective. If we don't see any change, then because the other animals are receiving nothing, the goats we know are not, the dewormer is not having any effect on the worm, and we'll have to look for an alternative solution.